Hi, good morning. Mr. Shirvin with you. In this video, we will explain vertex form and the standard form. This lesson is divided into 4 parts. First part, how to identify quadratic function in a standard form. First, we will recall vertex form. What is vertex form? Like what we studied before, vertex form y equal a x minus h power 2 plus k. And we named this form as vertex form because we can get a vertex easily, h and k, from this form. For example, y equal 3x minus 2 plus 5. Vertex is 2 and 5. First coordinate and second coordinate. This A is responsible for vertical stretch or vertical compress. In this case, we have A greater than 1, A is 3, so we have a vertical stretch. Another part, today we will study a standard form. This is a standard form. Y equal ax squared plus bx plus c. Standard form. We have here 3 parameters. First, a, b, and c. The three parameters are real number. Under one condition, this a can't be 0, because if a is 0, so the x squared term will be eliminated. If a is 0, 0 multiplied x squared, it will be 0. So x squared term will be eliminated, so the function will not be a quadratic one. But b can be 0, and in this case, if p equal to 0, if p equal to 0 in a standard form, so y will be equal ax squared plus c. There is no x term. In this case, this will be 0. If c equal to 0, so the function will be y equal ax squared plus bx. Okay? If p equal to 0 and c equal to 0, the function in a standard form will be like what we studied before, ax squared. A can't be 0 at all. Now let's study standard form in more detail. Y equal x squared plus 4x plus 5. Okay, this is a quadratic equation, a quadratic function. We have to get the 3 parameters. What is a? A is 1, the leading coefficient or the coefficient of x squared, 1 here. Okay, what is b? B is a coefficient of x, 4. What is c? C is 5, the constant. Now we will learn how to get a vertex from standard form. We have a rule for the first coordinate of the vertex, minus p over 2a. We will apply this rule, minus p over 2a. What is b? B is a coefficient of x. What is e? What is a? A is the leading coefficient. A is 1, b is 4. Then we can substitute 4 for p and 1 for a to get the first coordinate of the vertex. Let's do it. We have here minus 4 over 2 multiply 1. So minus 4 over 2, it will be minus 2. This is the first coordinate of the vertex. So this is the first coordinate of the vertex. Now we will get the second coordinate of the vertex, and pay attention for the second coordinate of the vertex. After getting the first coordinate of the vertex, this is what? This is the first coordinate. First coordinate means x. So x equal -2. So replace any x with -2 and evaluate the expression you have like this. Y equal open brackets power 2 plus 4 multiply open brackets plus 5. These empty brackets for x. So I will put inside these brackets the value of x, -2, -2, okay? And then evaluate here. So -2 power 2 is +4. Remember this. Minus 4 times -2 is -8. -8 plus 5. 4 minus 8 is -4 plus 5. So the second coordinate of the vertex is 1. So the vertex, it will be first coordinate -2 and second coordinate is 1. Now, in this part, we will study how to recognize a quadratic function. Look at the example 1. We have here determine whether the function represented by each equation is quadratic one. If so, give the axis of symmetry, give the axis of symmetry and the coordinate of the vertex. Firstly, to recognize a quadratic function, you must find x squared term after isolating y. Y here is already isolated. Ask yourself, is x squared term exist here? No. So it is not quadratic one. So it is not quadratic one, okay? Here, letter P. You have to isolate y, so y equal -3x squared minus 4. I moved 3x squared to other side. So minus 3x squared minus 4. Ask yourself, is the x squared term exist? Yes. So it is a quadratic one. Okay? Look at this reflect. Explain why the function represented by the equation y equal ax squared plus bx plus c is quadratic only when a is not equal to 0. Because we said before, if a equal to 0, so this term will be 0. If a equal to 0, the x squared term will be 0. There is no x squared term here, so it will be a linear equation, not a quadratic one. Now, your turn. I will give you 1 minute to solve number 6, 1 minute to solve number 7. Number 6, you have to isolate y. You have to isolate y. Firstly, this term will go to the other side, this term will go to the other side. So y equal x squared plus 4x. This is x squared plus 4x. So ask yourself, is x squared term exist here? Yes. So this is a quadratic one. Here, after isolating y, ask yourself, is x squared term exist? This is x and this is x. There is no x squared term. So there is no, it is not quadratic one. Explain 2. The second part of our lesson will talk about how to convert from vertex form into standard form. First, we have to remember how to expand binomial square x plus y power 2. How to expand it? First, we have to square the first term. First, use the same sign. First times second times 2, 2xy. This is the mid term, plus the square of the second term, y squared. So x squared plus 2xy plus y squared. Don't forget the middle term. Don't say x squared plus y squared. Middle term. First times second times 2. Look at this one. Here we have to expand binomial square first. So first step, you have to expand binomial square. This is 4, open brackets, for expanding, plus 3. Expand this one inside this brackets. First, square the first. First, use the sign. Use the sign, minus. First times second times 2, it will be 12x. Plus 6 squared, 36. Okay? Don't forget this. First and last term must be positive. Middle term, follow the sign of the binomial inside. Okay. First or second step is to use distributive property. We will multiply 4. We will multiply 4. Okay. 4 times x squared, it will be 4x squared minus 4 times 12, 48 x plus 144 plus 3. The last step for combining like algebraic term, 4x squared, 8x, 144 plus 3, 147. Sorry, 147. So we write, we convert it from a vertex form into standard form. Now letter P the same. Let's do letter P. Look at this one. Okay, y equal -3 and trinomial minus 1. Trinomial because we will expand trinomial squared into trinomial. First, x squared plus 4x plus 4. This 4x comes from first times second times 2. Then y equal -3x squared. We will distribute -3 inside the brackets. Minus 12x minus 12 minus 1. Okay? Then we will combine like algebraic term. There is no like for x squared, there is no like for x, but we have two constant, -12 and minus 1. So minus 3x squared minus 12x minus 13. Okay. Look at this reflect. If in y equal ax minus h power 2 plus k, if a equal 1, if this equal 1, he asked you, what is the simplest form for the standard form y equal ax squared plus bx plus c? A equal 1, so it will be x squared plus px plus c. Your turn. Rewrite a quadratic function from vertex form into standard form. So like what we did before, we have to expand binomial square. 2 multiply plus 3. This x squared plus 25 here, and the middle term will be 10x. Okay? Y equal, distribute 2 inside, 2x squared plus 20x plus 50 plus 3. Here we have 2x squared plus 20x plus 53. Okay, this about letter number 9. Number 10, you have a chance to do it. The third part of our lesson, writing a quadratic function given a table value. This is a table. Okay, he asked you here to use the table to write a quadratic function in vertex form. Okay, then rewrite the function in a standard form. Okay, the given, the minimum value of the function occurs at x equal -2. So at x equal -2, he will give you a minimum value. This is the minimum value, okay? So what does it mean? This is a vertex. This is what a vertex. This is a vertex H and K, okay? So now we have to rebuild a quadratic function in vertex form firstly. What is vertex form? Y equal a x minus h over 2 plus k. Is it right? What is h? H is -2, so we have to substitute -2 for h. So y equal a x minus -2, it will be plus 2 power 2 plus -3. Plus -3 means it will be -3. So plus negative, it will be negative. So I will erase this negative. Okay. Now we will get the value of a by using any point here. Any point. I will use the first point because x equals 0 and y equal 13. So I will use the point. I will use the point 0 and 13. Can you use any point? Yes, you can use any point as you like, okay? But I prefer to use this one. So we have to substitute y with 13 and x with 0, okay? And get the value of a. 13 equal 4a minus 3. 0 plus 2 is 2, 2 plus 2, 2 power 2 is 4, 4 multiply a, 4a, minus 13. Move 3 to other side, so it will be 16 equal 4a. So a will be what? Will be 4. So we got the value of a. Rewrite the equation again. The equation will be in vertex form, y equal 4 x plus 2 power 2 minus 3. So this is the equation in vertex form. We will convert it into standard form. Y equal 4 x squared plus 4x plus 4 minus 3. We will use distributive property. 4x squared plus 16x plus 16 minus 3. So y equal 4x squared plus 16x. Combine 16 minus 3, it will be plus 13. So this is a quadratic function in a standard form that represent this table. How many points are needed to find an equation in an equation of a quadratic function? How many points are needed to find a quadratic function? We have here 2 points, vertex and any point through the graph. Okay, look at your turn. First, the vertex of the parabola is 2 and 5. So this is the vertex. This is a vertex, 2 and 5. So this is H and this is K. We will write the vertex form, okay, and then get the value of A. Here also, the vertex of the parabola is -2 and 7. So we have, this is H and this is K. We will write this is H and this is K in vertex form. So first, number 12 again, we will write it, I will write in vertex form. Y equal A multiply X minus H. power 2 plus k. Here, y equal a multiply x plus 2 power 2 minus 7. Now we have to get the value of a. We have to get the value of a by using one of these points. I will use this point as x and this as y. So y is 11, a 1 minus 2 power 2 plus 5. So this is 11 equal 1 minus 2 is 1, negative 1. Negative 1 times 2 is a plus 5. So what is a? A equal 6. Okay. So here a is 6. We have to rewrite the function again. Y equal 6. X minus 2 power 2 plus 5. And after that, expand the binomial square and convert into standard form. The same, I will use the point negative 1 for x and negative 12 for y. You can use any point as you like. Okay, so y is negative 12 equal a multiply x is negative 1 plus 2 or 2 minus 7. So negative 12 equal negative 2 plus 2 is 1 power 2 is 1. 1 multiply a is a minus 7. So a equal, this minus 7 go to other side, so minus 12 plus 7 will be minus 5. So a is minus 5. We have to rewrite the function in vertex form like this. Y equal negative 5 x plus 2 power 2 minus 7. Now, the last part of our lesson, writing a quadratic function given a graph. I will give you a graph like this, and I will ask you to write a quadratic function. Look at this one. A rock is knocked off a cliff into a waterfall flow. The falling rock's height above the water in feet is given by the function of the form a multiply t minus h power 2 plus k, where t is the time in seconds after the rock begins to fall. So the vertex here, it will be this point. So the first point or the first coordinate is h and second coordinate is k. And this point is given to get the value of a. Look. So first we have the vertex of the parabola is 0 and 40. This one. Okay. F of t equal a multiply t minus h power 2 plus k. This is a given function. So a multiply t minus h is 0 plus 40. H and k, I will replace h with 0 and k with 40. So after simplifying this one, so t minus 0 is t power 2 t square, a multiply t square plus 40. I will use the point 1 and 24 to find the a. 1 and the 24 to find a. So we have here a mistake. This is 24. 24, okay? So the point 124 to find a, f of t equal a t power 2 plus 40. F of t is 24. This is y. Okay, this is y, or f of t, f of t, okay, and this is x, or t. A multiply 1 power 2 plus 40, so we got a equal negative 16. So the function will be negative 16 t squared plus 40. Your turn, look at this one. We have here point, a vertex, h and k, So h equal 1 and k also equal 1. And this point I will use it to get the value of a. Let's start. First, y equal a x minus 1 over 2 plus 1. Y equal x squared minus 2x plus 1 plus 1. So I expanded this one here. Sorry. We have to use the value of the second point here. This is x and this is y. So negative 3 equal a multiply 3 minus 1 power 2 plus 1. So this is x, 3, and this is y. So negative 3 equal a multiply 3 minus 2. 3 minus 1 is 2, 2 power 2 is 4, plus 1. So minus 3 minus 1 equal 4a. So this is minus 4 equal 4a. So a equal negative 1. Okay? After getting the value of a, we have to rewrite the function again. Y equal negative 1 x minus 1 power 2 plus 1. Elaborate. Describe the graph of the quadratic function. It is parabola. What is the standard form of the quadratic function? Y equal ax squared plus bx plus c. This is a standard form. Can any quadratic function in vertex form be written in a standard form? Yes. How many points are needed to write quadratic function in vertex form given the table of the value or given a graph? 2 points. One of them is a vertex. If the graph of the quadratic function is given, how do you find the vertex? We have to look for the minimum or maximum value of the graph. If you get the minimum or maximum value of the graph, so you can get the vertex. Okay? What can you do to change the vertex form function to standard form? Okay, next. We have this homework. First, determine whether the function is a quadratic function by graphing. Okay, ask yourself, is x squared term exist? Yes, exists here. So this is a quadratic function. The graph is parabola and it is a quadratic function. Number 2, is x squared term exist? No, we have only x. So not parabola. It is not quadratic function. Is x squared exist? Yes. Is x squared exist? No, this is exponential 1. 2x exists as exponent, so it is not quadratic 1. The same. Is x squared exist? No, so it is not function. Is x squared exist? Yes. Yeah. We have to isolate y, negative 6 to other side, so 2x squared. Yes, we have. This is a quadratic function. Number 7. Yes, because x squared term is exist. Y plus 6x equal 14. There is no x squared, so it is not a quadratic function. Okay, which of the following is a quadratic function? Select that apply. This is not quadratic one because there is no x squared term. This also not a quadratic function. E, not a quadratic function. So we have here x squared. So this represented by a quadratic function, and this also. Okay. For a function give the axis of asymmetry and the coordinate of the vertex. We have to get the axis of symmetry. To get the axis of symmetry, we have to get minus b, or first coordinate minus b, x equal minus p over 2a. What is b? b is 8, so minus 8 over 2 times 1, because a is 1, okay? So minus 4. The first coordinate is minus 4. We have to substitute to get the value of y, x squared plus 8 multiply x minus 14. So I will put inside these brackets, I will put inside here negative 4, because this is the value of x. We got the value of x before, the first coordinate. So this is 16 plus negative 32 minus 14. And after that, get the value, negative 13, okay? So we have to get minus p over 2a first, then the first coordinate will be minus 4. Substitute for x equal negative 4, you will get it negative 30. So the vertex is negative 4 and the negative 30. So the axis of symmetry is x equal negative 4, and this will be a minimum value. Minimum value. Why minimum value? Because we have a greater than 1. So the parabola will be like this. The parabola will be like this. So we have minimum value, a greater than 1. Number 11. Describe the axis of symmetry of the graph of the quadratic function represented by the graph y equal ax squared plus px plus c when p equal to 0. P equals 0, so there is no x term. There is no x term. The axis of symmetry in the y-axis is the y-axis itself, or x equal 0. Why? Because we have a rule minus p over 2a. In this case, p is 0. 0 over any number, it will be 0. This is the value of x. So x equals 0. X equal 0. This is the equation of y-axis. Okay, rewrite each quadratic function from vertex form to standard form. We will expand this, we will expand binomial square. Number 13. 14. 15. Okay. Explain the error. Tim wrote negative x plus 2 power 2 minus 10 in a standard form as this one. We have to expand this firstly. Yes. X squared plus 4x plus 4. This still expand binomial square, distributive property. 6 multiply x multiply 4 multiply 4 again. And if you combine, you will find instead of 14, it will be 34. How do you change from vertex form into standard form? Expand the squared term, then distribute the a value finally. Combine like algebraic terms. Okay, rewrite or write a quadratic function that represents each table here. The vertex is 6 and negative 8. So this is h and this is k. So this is h and this is k. And you can use any point to substitute for 0, y for 0, and x like what we explained before. Here, 4 and 7. So 4 and 7 is a vertex. Yes, he choose the value of this point. This is as x, and this is as y. And the vertex, this h, and this k. Okay, in the form y equal a x minus h power 2 plus k. Now we will study focus on a higher order thinking. We have here a graph. We have a vertex h0 and the k equal 20, and we have a point through the graph. You can think. Check for reasonableness. 10 hits a football. Okay, from the graph we can deduce that 1.5 is h and 40 is k. This is h and this is k and this is a point. You will use this is x and this is y to get a. So you can use this solution.